All right, guys. Welcome back. Hope you're doing well. Today we're going to talk about linear relations, functions, and writing linear equations. Still kind of a review from Algebra 1. We're still in that area where I introduced some new material, but not the whole lesson is new material, okay? So today we're going to talk about what is a linear function, evaluating a linear function, which isn't bad. We've done that already, technically. And then to finish it up, we'll talk about standard form. That's it. That's part one. Part two of the lesson, which will be a different video, we'll talk about point-slope form, slope-intercept form, and just working with those, which is a review from Algebra 1, but it's been a long time, right? You took geometry before, so it's been a year. So let's go ahead and get started. Quick warm-up problem. Determine whether this relation is a function, and then what type of function it is. Pause the video so you can decide for yourself. Okay. The answer for this one would be B. It's a function, and it's a onto function. Okay, that would be the one for this guy. The reason why it's not one-to-one, see how 46, the output got used twice? Nothing's unique, so not everything's unique, I should say. So that's why it's not one-to-one. Next one. Is this a function or not? Okay, answer for this one, ironically, it's B. Okay, it is a function, and it's onto. The reason why it's not one-to-one, if you take a look, I have y values being used more than once. Okay, so it's not going to be a one-to-one unique situation. If you do the vertical line test, it's another way to determine if it's a function, and it passes. Okay, so we analyze relations and functions. Now we're going to identify linear relations and functions and how we can write these in standard form. So that's today's lesson. So there's some vocab we'll take a look at today. So let's go ahead and start with the first one. Okay. State whether g of x, 2x, well, I can't talk. G of x is 2x minus 5. State if it's a linear, and then explain. Okay. Well, looking at this, we know this is a really general graph of it, that this is a line. It has a slope, it has a y-intercept, right? This is just like me saying y equals 2x minus 5. The only reason why I don't is because I'm telling you it's a function. Okay, that's really all it's there for. So is this guy a linear function? Yeah, it is. It is linear. What's something that you notice about this? Well, see how the variable has a power of 1? When that variable changes, it's no longer linear. Okay? For instance, we know that x squared is a parabola. Okay? When that power starts increasing, the linear part of a function is gone. Okay? It's no longer linear. So that's the real reason for this, okay, is because the power of the exponent is 1. So that's why it's linear. Okay? Look at the next one. State whether this guy's a linear function. Answer is no, it's not linear. Okay? The primary variable x is being cubed. Okay? And if you notice, if you remember from Algebra 1, that cubic graph looks like this. Okay? It's not linear whatsoever because the power is bigger than 1. Last one. This function, I don't think we've seen that before, but this function has 2 variables. That's what this indicates, right? The function name is g. The variables are x and y. So 3xy. Is that going to be linear? Okay, the answer is no. If you notice something, linear functions have this format. Y-intercept and slope. If you look at that, we have 2 inputs. 2 different variables here. Linear graphs only have 1. So this is no. Okay? 2 variables are being multiplied together. It's not going to be linear. Okay? It just varies. It really does. If I put x to be 1 and I give you y to be negative 1, okay, there's a point. But then let me switch it, because I have two inputs, I could have a graph that looks like this, depending on what I plug in for x and y. So it's definitely not going to be linear in this one. Okay? So evaluating a linear function. So we'll do two of these just to kind of get us warmed up here. Okay? Meteorology, the linear function, as you can see, can be used to find the number of degrees Fahrenheit that are equivalent to the number of degrees in Celsius. Okay, we've seen this before. We're just going to work with it a little bit. On the Celsius scale, normal body temperature is 37 degrees Celsius. What is the degrees in Fahrenheit? Okay, so this is the function that we're going to use. And this is just a substitution problem. Really, it's just, can you write this using the proper notation? It's just more practice from the previous lesson. So I know that this is function f. Okay, it's named f for Fahrenheit, which I can see that. C is the variable, which means you tell me what the Celsius temperature is. Function f will give you the Fahrenheit temperature. Okay, so I'm going to go ahead and plug in 37 degrees. So it's 1.8 times 37 plus 32, just like that. Okay. Once again, it's not a difficult problem to evaluate. It's just, can you write this properly? Okay, that's important. So, simplifying just a little bit here, we get 98.6 degrees Fahrenheit. So what do you think? Is that matching normal body temperature? I think it is, right? So we can confirm. Not too bad. Just plug in a number. Okay. If the temperature is 100 degrees Fahrenheit, what's the temperature in Celsius? Okay, I flipped it a little bit. So the temperature in Celsius, that's what I want to figure out. So I already know my y value. I already know the output. It's 100 degrees Fahrenheit. But I want to know what it's going to be in Celsius. So I just switched the input value. Okay, that's all I did. So now I'm looking at this guy right here. So in other words, what f of c gives me 100? What c value gives me 100 degrees? That's what this says. So I plugged 100 degrees for the f of c part. See how I just kind of flipped them out? Okay. Subtract 32 to the other side, so I get 68 equals 1.8 degrees Celsius. Okay. Divide those sides by 1.8. We get 37.78 degrees Celsius. Okay? For that guy. So f of 37.78 gives me 100 degrees Fahrenheit. That's my final result. Okay? So I just messed with the notation a little bit. But it's still a substitution problem when you come down to it. You know, what am I plugging in? If I have it in parentheses with a number, I'm plugging that in for the variable that's in question, which is c. If the variable's here and I'm equaling it to 100, then that's my output value, equals the equation. And I'm going to solve for the variable to figure out what input value gives me that output value. Okay? Any questions? No? Okay. Sounds good. All right. So let's talk about standard form. So while I'm erasing this, you can write down the definition for it. Standard form is written as thus. Okay? That's one way to write an equation. We're used to probably slope-intercept form. That's like drilled into your brain. Okay? But not every equation we come up with is going to be written as such. It could be written as a standard form. So it's ax plus by equals c. A, b, and c are integers. And here's the important part. You can highlight it, underline it. The greatest common factor is 1. So for A, B, and C, the greatest common factor is 1. A and B cannot be 0. Okay, that's the other important thing. So they give you some examples. So look at the examples real quick. 3x plus 5y equals 12. 3, 5, and 12 is the GCF 1. Yeah, it is, right? Okay. There's not another number that can go into those guys except 1. So that works. So that's the important part here. A lot of people can rearrange the equation to get x's and y's to one side. That's not an issue. It's just making sure that the greatest common factor is 1. Okay? And of course, the other thing, a, the first value cannot be negative. Okay? That's important. Alrighty. Ready to give it a shot? Try an example out? Okay, here's the first one. So we have y equals 3x minus 9. And we're going to write this in standard form. Okay? So right now, does this look like this? No. So let's do that. Y is already over here, right? So let's bring x over here. So we'll subtract 3x to both sides. Negative 3x plus y equals negative 9. That's what we have so far. Okay? Now going back to the definition, I'm not allowed to have this guy to be a negative. Okay? It needs to be positive. So I'm going to divide everything by negative 1 to change this guy. So 3x minus y equals 9. Okay? That's it. That's my final answer. So this is written in standard form now. My a value is 3, my b value is negative 1, and my c value is 9. Okay? Now, question. Is this the same as this? It is. Okay? I just changed the format of it. That's all it is. Okay? Now, why did I change it? Why even change to begin with? It honestly depends on the problem. Some problems, the information you need, you can get it quicker if it's in standard form than in slope-intercept form. Okay, in this case, you really wouldn't say that, but in other cases it could be. Okay, so just kind of keep that in mind. We're just changing the way it looks to possibly get information a little bit faster. Okay, so let's look at the next one. All right, and I'm going to write it down here. So y equals negative 2x plus 5. And you want to write this in standard form. Okay, we can do that. So I got to get x and y on the same side. So I'm going to get the x's over here. 2x plus y equals 5. All right. Now, does that look like standard form? I believe it does. Okay. In fact, I think we're done. 2, 1, and 5. Is their greatest common factor 1? It is. So there's nothing more to do. Here's my A, B, and C values. So what option would that be? C. So C was the correct answer. Let's change it up. As much as it's nice to have, basic examples like this, what if we have fractions? What if we have decimals? What do we do? Okay. Let's talk about those examples. Go ahead and write this down. So we have what? 4/5 y plus 1/8 x equals 4. Now I want to write this in standard form. Okay. Well, is it kind of written that way already? I think it is. I mean, could I switch these? Yeah. You want to do it now? Let's just do it now. Let's switch them around. Okay? Makes it easier. Now, the question is the greatest common factor 1? Answer is no, it's not. Okay? So what could we do? Well, here's an easy method to solve this guy. Look at the denominators, 8 and 5. What can I multiply 8 and 5 by to get rid of these fractions and just have whole numbers? What can I divide by? Or not divide, multiply by? Well, the number is 8 and 5 multiplied together. It's 40. Okay? Watch what happens when I multiply both sides by 40. Okay? 40 times an eighth. Okay, what's that going to be like? Well, take a look. And did I make a mistake? No, I didn't make a mistake. It's because I reversed it on my PowerPoint slide here. Okay, making sure. I was like, wait a minute, is that what it is? Yeah, it is. So 40 over 8, is that just 5? See how that comes out to a whole number? Over here, 40 times 4/5, I think that's going to be what, 32? Why? 40 and 5 can reduce. 5's gone, that becomes what, an 8? 8 times 4, 32. And 40 times 4 is 160. Just like that. Now, since we already put the x's first, now we take a look. Is 5, 32, and 160? Is their greatest common factor 1? Answer is yes. And to be honest, the easiest way to look at it, 5 doesn't go to 32. Okay, 5 goes into 60, but despite the fact it doesn't go to 32, then I already know that this is probably a GCF of 1. Okay, so you can use one of the other numbers to help differentiate that just a little bit. So now my A value is 5, my B value is 32, and my C value is 160. We're done. So when you have a fraction, multiply, okay, by a common element, okay, common multiple that both of them can go into, and usually if you just multiply them together, that's the number, okay. Get rid of the fractions, and then just see what's left over. And you can get your GCF of 1, which is what you need, okay. Let's try another. We have 2.4y, negative 14.4x. Write that in standard form, identify your A, B, and C value. Okay. Well, I know when I bring the x's over, they're going to be positive, and it's supposed to be positive, right? It has to be bigger than 0. So I'm going to do that just out of ease. So I'm going to add that to the other side, just like that. So on the other side, we get 0. Okay, is the GCF 1 in this case? No, it isn't. How do I know? Well, with decimals, it might be a little tricky. Usually what I do is I'll take the smaller number and divide it into this guy. Okay, and if it works, then great. Then I know I can reduce everything. So that's what I did. I said, okay, can 2.4 go into this guy? And remember, whatever I do to one element, I got to do to the other side, right? To keep the equation balanced. And it does work out, okay? So 2.4 divided by 2.4, I just get a y left. This is just 0. 14.4 divided by 2.4 is 6x. Okay? I think I'm done. 6, 1, and 0 is the GCF 1. I think we're safe to say yes. This is the A value, this is B, and this is C. To wrap it up. So when it comes to decimals, take one of the decimal values, divide it into the other guys, see if it comes out. Okay, if it does, then you can further, simplify this. So we started out with just a bunch of decimals, but look what it's simplified down to. Nothing but whole numbers here. And that's great. That's great to see. So what would you rather deal with? This guy or this guy? I think this guy's a little easier to work with, right? So standard form wasn't bad in this case. Same thing up here. What would you rather deal with in this case when it comes to plugging numbers in? Okay? Makes sense? All right. Let's keep it going. Find the x and y intercept of the graph. Okay? So what are we going to do? Well, x-intercept, y-intercept. When a graph crosses those axes, x and y, the other value is 0, right? If you cross the x-axis, the y value is 0. If you cross the y-axis, the x value is 0. So this problem literally just tells you, hey, plug 0 in for x, what do you get for y? And do the same thing with the other variable. That's it, okay? So let's try it out. So I'm going to go ahead and we're going to plug 0 in for x, okay? So negative 2 times 0 plus y minus 4 equals 0. Okay? So this is 0, so y minus 4 equals 0, y equals 4. Okay? So there's my first intercept. Okay? In particular, it's the y-intercept, right? That's what we just found there. Now, let's find the x-intercept. So that's when we put y0 in here. So negative 2x plus 0 minus 4 equals 0. So this is gone. We can add 4 to the other side. So x is going to be negative 2. So now we're going to have negative 2 and 0. So here's the x-intercept. Here's the y-intercept. Okay. Now, what does this look like? And to be honest with you, I forget if I left it on the PowerPoint or not. Yay, I did. All right. I update these things all the time, so this is one of those cases where I don't remember if I did. So here's what it looks like. We can use the two intercepts to plot 2 points, because it's all we need to create a line, and then draw it. That's what the graph looks like. Okay, so looking at this, would you be able to tell what that looks like just by looking at it? Probably not. Okay, if you could, great. If you couldn't, that's fine. So to actually graph this, if I plot the intercepts, that's all I need is just 2 points. And then I get a good general look of the line. Okay? Should we be more accurate? Yeah, we obviously should. We should plot a couple more points there. But if we're just doing a rough sketch just to see what it looks like, that's not a bad rough sketch. Okay? Questions, thoughts, concerns, dilemmas? Well, you're going to have to email me because I can't hear you. Sorry. Next one. And what are the x-intercepts and the y-intercepts of this graph? And this is actually our last problem. Hopefully the video is not going to be too long for you guys. Hope it not. So this is written in standard form. Okay? So let's go ahead and find the intercepts. Let's plug 0 in for x first. No reason why. Just because I said so. So this is gone. Negative y plus 6 is left. Carry the 6 to the other side. We get negative 6. And then divide by the negative 1 to finish. So there's our first intercept. So 0, 6. So there's my y-intercept. Let me put that down. Y-intercept. Now, we're going to plug 0 in for y. So 3x minus, minus 0 plus 6 equals 0. Subtract 6 to the other side, so 3x equals negative 6. So x is negative 2. So negative 2, 0 is my x-intercept. So what option is that? I'm going to say A, right? A would be the right one for that guy. Okay? That's it. That's part 1. Okay? Knowing what a linear equation looks like, which has one input, and the power of the exponent is just 1. Anything other than that, not linear. Okay? How do you evaluate a linear function? We did 2 different examples. One where you just input for the variable. The other one when you input for the output stuff. If that made sense, if I said that correctly. And then to finalize what standard form is, how to work with it, and how to find the x-intercepts to graph. Okay? So did a couple examples, one with fractions, one with decimals, just so you have that in your notes in case you come across those. Okay, that's part 1. Not too bad, right? So if you have questions, feel free to email me. Be glad to answer them for you. Other than that, have a good day, guys. See you in the next video.